My name is Stéphane Servo, and with my partner at Igalia, we're going to present you our work this year on Vulkan video inside GStreamer. So this is the 2024 edition, because last year we had a presentation. So I'll let Victor start to present the Vulkan part.
Okay, let's jump. It's just two parts, this presentation. First, the Vulkan video part, and the next, the GStreamer part of this. Just a quick review. What is Vulkan? Basically, it's a low-level graphics and compute API. It's supposed to replace or intend to replace OpenGL. And both APIs are under the Chronos umbrella. The thing is that Vulkan doesn't make any assumption about how the hardware works. It's exposed how the hardware works directly or most directly, just giving the tiniest abstraction of it. So the drivers can be less complex, but it delivers all the complexity to the application. The specification is under the Apache license 2 ones, but the drivers can be in any other license, and applications can be in any other license. In 2018, the technical specification group for Vulkan video was created, and this was driven by the AMD, NVIDIA, and Intel. And in time, we jump in, other FMPEG, GStreamer, Igalia, Collabora has also been there. And until 2021, in April, we have the first provisional extension for both decoding and encoding for H.264, H.265. But until December 2022, because we have how Vulkan works is you propose a provisional extension, then it passed time, and now it's ratified by the whole group and passed as a release version, and that happened in December 2022 for decode H.264 and H.265. 1 year later, encoding was released with another modification or an update in the API, and every update in an extension has a label, a tag. In this case, it's video maintenance 1, and now we are preparing video maintenance 2, and so on. And in February 2024, the AV1 decoding extension was released, and now we are preparing for release the AV1 encoding. So the goals of the Vulkan video is to provide hardware acceleration for different video codecs in either PCs, handhelds, mobile, GPUs, well, and so on. So vendors cannot be tied to a different, because normally we have different silos and wallet gardens for video processing. So we have the Intel BA, the MV codec for NVIDIA or VDPAU. We have D3D for Windows. So this is, the joke from XDC that we have any specification. Let's create one for all, and I have N+1 specification. Perhaps this is more the case, but the spirit at least is to have a single one that is agree among all the players that are involved in the Chronos group to have this. So now there is, we'll see now. And we can also have a solution to interact with other elements that still it's not trivial, but at least have a mechanism to share to the native or to the rendering parts of the pipeline. And also now, Vulkan video is a first-class citizen in the Vulkan specification. Even though the Vulkan specification is big, basically with all the specification for Vulkan video is twice as big. It's only for video the codification. So it's a huge extension. Just as an overview, it's a stateless codec, just as a VAPI, as a D3D11, as a video for Linux stateless. It's cross-platform, very non-neutral. It's a very low level. The thing is that, as I said earlier, it provides, you can query the hardware and it will tell you all the little details of that hardware that as a developer you have to enable different code paths according what the capabilities of that specific hardware is providing. So as I say, the complexity was moved out from the driver to the application. It's good, it's bad, we'll see. It's a closer integration with graphics and display because we are sharing the same abstractions for sharing images and sharing buffers with other Vulkan parts. And it's changing over time, so we have to have different maintenance and updates in the specification. So it's a general view of the architecture. We have the Vulkan core, which provides all the allocators, buffers, etc., images, etc. We have the Vulkan video core, which is the common generic part for all the video stuff. We have a common area for decoding, a common area for encoding, and then there is the specific codec structures and functions, either for encoding, decoding, and even though there's the new development thing that is the BP9, for example, or quantization maps or adaptive quantizations, etc. In the case of codec supports, well, this is a very we will talk about this later. So the story to have a ratified extension in Vulkan is you have to have the final specification, you have to have the different drivers for different vendors, and you have to have the Vulkan validation layer and the conformity testing suite. I have to say something about the validation layer because Vulkan doesn't error you instantaneously. You say something and Vulkan will say, okay, accepted. I don't know. Whatever you will get about after that, I won't tell you. If there is an error, it's up to you. So basically, you need a layer, which is something that you put in the middle of the application of the library in between the API and the driver that will tell you if you are misusing the API. Say that it's agreed that the validation layer won't tell you nothing about the codec specific things. You can have errors in the codec thing, and the validation error won't save you that. That's up to you and the driver and nothing else, because that will increase the complexity, which nowadays is very complex, the validation layer. It will increase in several orders of magnitude the complexity of the validation layer. So it's a no-go.
This is still under discussion, but yeah, this is a lot to add, and that's why it's a no for now, but yeah.
And we got the conformance testing suite, which it's a conformance test, and it will tell you how to operate with the API. And nowadays there's the encoding, the coding for H264, H265, AV1, encode H264 and X265, and in the pipeline is the AV1 encoding, and the BP9, the whole set, the encoding and decoding is also been talked about. Drivers, what we have now, what vendors we have now on board is NVIDIA, only for the proprietary for Windows and the proprietary for Linux that support all what is supported. The AMD, we have the proprietary driver for Windows, and in Linux we have the Mesa provided one, open source for RADV, mostly done by Dave Arley, and it also supports all the available codecs. In Intel we have the proprietary driver for Windows. And in Mesa, we have the MBL Linux, which also was developed by Dave Arley and Igalia. And also there is a new thing also done by Dave Arley, which is the Sync Video Experiment, that basically it receives gallium video messages and emit Vulkan video commands, which allows you to have perhaps any other API, video API, just like BAPI, and if your driver only supports Vulkan, you will get the video there. And now,
let's talk about GStreamer. So, what is GStreamer? No, it's a joke. I'm just like think this because we're having now a very nice interaction between Vulkan and GStreamer. We already had something for a while. It has been interacting with collocation or some display, but now we're having also the encoding and decoding capabilities. So The implementation of we're having right now is the conformance test suite, as we said before. We're having also VK video samples, and we are us at Igalia, we have been working on the conformance test suite in addition to the GStreamer elements. So we're having decoder elements we're going to see later, and encoding elements. There is another implementation, is FFmpeg, released in 7.1 the encoder, so recently, I think it's 2 weeks ago. And FFmpeg 6.1 was shipping AV1 and H.264, H.265 decoding. So let's talk about the decoder in GStreamer. So the GStreamer decoder for H.264, H.265 have been released in 1.24. So I think it was in December last year. It has been merged and released in the 1.24. And you can see in the slide that we are having like a quite good result for cluster. We're still having room of improvement, but yeah, like as you can see, the RADV is having a very good result. NVIDIA is still ongoing. There is like that's what we were explaining, that this is quite straightforward to support Vulkan for different driver, but there is capabilities to respect, and some driver doesn't support, for example, the separate DPB, when we were in the beginning only supporting separate DPB for decoded picture buffer. So as you can see, like the three hardware are supported for both Windows and Linux. No. So now let's talk about the encoder. So the encoder, the object GST Vulkan encoder has been merged in 1.25. I think it's like four months ago, and there is like unit test to demonstrate exercise the encoder. So it's possible like to encode a very naive frame. We are working on the encoder elements because we are still working on the encoder elements because we are discussing about like an encoder base class. We want something generic and which could be used by another implementation such as VA or D3D. So there is like a solution in Polish mode. In work in progress. We're going to discuss it during the access, I guess. And but right now we're having elements ready that are supporting I and P and B frames. I think at the last GStreamer conference we were just having I frames. So we need more love on the encoding rate control. That's something we don't support very well right now, but that's part also of the base class. We need to know where to deal with that, because there is a lot of facilities in Vulkan to support that. And for the encoder, we're having the AV1 in the pipeline. There is already like a unit test ready, only for iframe. That's breaking news because it has been ratified recently, the AV1, and but it's not released still. Let's talk now about the challenges we got implementing these elements supporting Vulkan video. So the first one is I would say in the reverse order, because we have been working a lot on the Vulkan classes. Victor and I have been working on synchronization, being able like to have the right command at the right moment, because we need to exchange with the driver and commit state with the driver. So a big effort has been done on GST Vulkan operation. And we both implemented also the helper object, the helper class, the GST Vulkan decoder and GST Vulkan encoder, to be able to support different codecs, agnostic of the codecs. He's getting structure out of the child class. Then I do it at the reverse order, that we work on the base class for decoder and encoder. The base class decoder was already ready, that we use the one used in VA. But for the encoder, we implemented something. We got inspiration from the VA encoder, and we decorrelate what was done in the VA encoder to create a base class. Was able to support the GOP handling, and also some parameter set support. The other challenges we got definitely are the use of Vulkan, discussing with the driver. We had to support 3 hardware with bleeding edge drivers, proprietary, not proprietary, but like in debugging Mesa driver. And so yeah, it was either alone in the dark with the driver, because the driver we got, proprietary driver was the most advanced, but it was crashing, and sometimes like validation layer was giving some information, sometimes it was not. So it was a back and forth at first with the validation layer, because also validation layer can be different in when it's different hardware. The validation layer adapt itself to the hardware. So yeah, it was a lot of decryption of the validation layer messages, because the message is clear, but I don't know if it's clear at the end. No, it's clear, but but it's not. Yeah. It's another language. So yeah, and so we had also a really nice toolbox in Vulkan. Very useful tool we have been using. It was GFE reconstruct, or the API dump layer, where it's possible to record the command we send to the driver and replay it. So it was very useful to compare with other implementations, such as CTS or even FFmpeg. So next, what's happening next? Definitely the AV1 support, decoding and encoding. As I said, we're having like a unit test ready, but yeah, we would like to implement the elements as soon as possible, at least the decoding. The Vulkan video maintenance extension support. We're having some really cool feature ready to be used, such as inline queries who can help, who can fast up the decoding and the encoding process. The QP map support, the entire refresh. There is plenty of stuff coming. Video maintenance 2 is about to be ratified also. There is like, yeah, there is stuff to implement. The color space management, definitely right now we're having a lack on that. We support only NV12 and 8-bit. We would like to support other color space. Definitely the zero copy is also something missing. We're having a conversion issue in the video Vulkan color convert element that we should fix soon. And yeah, to make Fluster happy with the decoder, like having like a real decoder. I mean, it's a real decoder, but with more better results. So here is like on screen. I don't know if you see something. I guess but the idea is like to demonstrate how it works. We're having the video test SRC. We're having the Vulkan upload element, who is like converting the data into Vulkan memory. The Vulkan encoder speaks only with Vulkan memories. That's why we need the Vulkan upload. Then I put like a H.264 parse to parse the data to verify that the data is well formed and provided to the Vulkan decoder. And then we need a Vulkan downloader to convert the Vulkan memory into GStreamer memory. And that's all. So thank you. And if you're having any question.
Questions? You and the folks.
Thank you. Hello, wonderful.
Hello.
I wanted to ask about the implementation of the helper that you were explaining before, this Vulkan decoder helper. I understand it's about the limitation of a single inheritance with the base video decoder on one side and on the other, the common code between all the Vulkan decoders. It's about that?
No. It's just an isolated object. It doesn't descend. It's just descend from GST element, no, GST object, and it provides the Vulkan specific structures to make a code. So basically, when we join, for example, the GST video info with the DPV of an array of other buffers, and we pass all that, and in that function, in that huge function, we got actually the decoding. And also it gets the capabilities of the driver. Basically, it's like wrapping the Vulkan specific things to get it translated to the GStreamer
Okay. And
language.
that part, and I understand that that part is common to all the different codecs implementations that you have, right? Not really.
It's the name of agnostic. Sorry, agnostic to the, because it's only Vulkan thing.
Okay.
The generic thing.
To explain a little bit, like this GST Vulkan decoder is the Vulkan video core part. It's like and all the Vulkan video decoder H.264, H.265 is in another child class.
In the element itself.
Yeah, in the element itself.
Okay, thank you.
Hi, hello. So I'm trying to compare Vulkan with OpenGL. So in OpenGL, you have shaders to access every pixel in the texture. So what's the replacement in Vulkan for that?
There are also shaders in
There are
Vulkan.
also shaders. Yeah.
Okay, so, okay.
Basically, most of the things that you can do in OpenGL can be done in Vulkan.
They move the complexity of the driver outside of the driver, like to let the developer be more flexible and avoid like crashes in the driver where they don't have like any, or we don't have any
Insight.
insight, exactly.
Okay, thank you.
We still have crash in the driver, unfortunately, but it's better.
Over there.
Yeah, just a quick one. What's the overall vibe? How close is it to something that could be like used in production?
Today, no.
that much I gathered, but like
Perhaps,
years away, months away, decades away.
No,
not decades away. No.
I'm thinking in a year to something like that.
Yeah.
Yeah, we have a hackathon tomorrow, right? Okay.
Something else? So
Another question?
thank you very much.
Yeah. Thank you very much.